Hey guys, how's it going? Back here with day 57. Today we're going to look at some more U sub problems. So let's take a look, dive right into this first one. What I see here is the integral from 0 to pi over 2 of sine to the fifth x times cosine x dx. Now again, when we see that notation of sine to the fifth x, we want to think about that as sine of x to the fifth. When we think about it like that, we can see, oh yeah, this could be a u substitution because I know sine's derivative is cosine. So I can just let u equal sine of x because then that cosine x dx would come out in the du. That's exactly what I'm going to do. If you ever see a problem with sine to a power times cosine dx, let u be sine. If you see cosine to a power times sine, let u be cosine. Let u be the one that's raised to the power. Don't include that power in your u, right? I want u to simply equal sine of x. Because then my derivative, cosine of x dx, comes out. If I let it be sine to the fifth x, my derivative would be a chain rule, and it'd be 5 sine to the fourth x times cosine x, which is not showing up. So I'm going to let u equal sine x. Du then equals cosine x dx. Notice I don't have to do anything to make it match. It already makes it match. No adjustments needed. So I'm going to put my integral sign, my du at the back. Again, du is accounting for the cosine x and the dx. And what I have here is sine of x to the fifth power. But remember, sine of x is equaling u, so what I really have is u to the fifth power. Okay. Now, I have to adjust my limits here. When I plug in 0, sine of 0, I know from the unit circle it's 0. When I plug in pi over 2, sine of pi over 2 equals 1. And this is no longer a trig problem. It's a simple definite integral. So I can go ahead and solve. I never have to go back to x, right? So when I solve this, my divide gives me 1/6 u to the 6th. I'm going to take that 1/6 and throw it out front. So what I have is 1/6 times 1 to the 6th minus 0 to the 6th. That's 1 minus 0, which gives me 1. 1/6 times 1 gives me 1/6. Next one. Now, when we look at this problem, this looks like a classic u substitution, right? That's what a lot of people think here. Okay, what I'm going to do right now is going to be wrong, and I want to show you why it's wrong. What a lot of students do with this problem is they let u equal x squared plus 4. And then they say, okay, so that means du is 2x dx. And they adjust with a half. The problem with this, okay, is that this x is in the denominator. This x isn't in the denominator. How do I put a du in the denominator? That doesn't make any sense. This is all wrong. This problem is solved actually without using u substitution. Okay? What I want you to notice here is this. Remember this? See the heart? Right, when I have a binomial on top, and a monomial on the bottom, I can see the heart and split it apart. So the correct way to do this is to rewrite this integral as x squared over x plus 4 over x. X squared over x reduces to x. I'm going to split this integral and factor out the 4 to make it more simple. Can I split the integral? I simplified x squared over x to make x. And I took that 4 and I just moved it out in front, right? Because I can always do that with a coefficient, and left it as 1 over x dx. Well, what's the integral of x dx? Well, I got to bump and divide. I'm going to bump my power up to 2 and divide by 2. Plus, what's the antiderivative of 1 over x? Well, that's ln absolute value of x. Let's see. Didn't use any u substitution here, so just be aware of it, right? If this was reversed, if it was x over x squared plus 40x, it'd be your classic u substitution. Okay, the last example I'm going to look at is kind of a tough one, okay? And I'll show you how we can do it. Okay, so when we take a look at this problem, I'd say, hold on, wasn't that supposed to be x squared on the bottom? No, this would be a pretty easy problem if x squared was on the bottom, if that was x squared plus 5, but it's not. And you say, oh, can we just split the heart? No, because the binomial is in the bottom. You can't split that. So what can we do here? Well, this becomes a little bit more challenging of a problem, okay? But it is a u substitution problem, okay? We don't see these problems very often, but you never know when one crops up. So what I'm going to do is I'm going to choose u to equal the denominator x plus 5. My du then would simply be dx. When I go to rewrite this thing, I never accounted for this x that was on top. Well, let's think about this really quick. Okay, I'm going to put my du at the back. That's taking care of my dx. The bottom is nice and easy. That's just u. I can adjust these things, right? 0 plus 5 is 7. 2 plus 5. I'm sorry. 0 plus 5 is 5. That's getting out of myself. 0 plus 5 is 5. 2 plus 5 is 7. Now, I can't just leave the top as x, because this thing has to be entirely made up of u. So what I'm going to do to replace that x on top is I'm actually going to adjust my u equation, right? So if u equals x plus 5, that means x equals u minus 5. And just subtract 5 from both sides. So what I'm going to do is I'm going to call that x on the top, I'm going to call it u minus 5. Okay? Now, this doesn't look any better, except for the fact that we now have the heart that we can split. So this is going to be the integral from 5 to 7 of u over u du minus, again, I'm going to split the integrals, 5 to 7, 5 over u. Okay. U divided by u equals 1. I'm just going to take that 5 out front, call When I integrate a constant, I just tack on the variable. I'm going to solve both of these. The antiderivative of 1 here would be u. The antiderivative here would be ln absolute value u. Okay. Almost done here, then this would just be 7 minus 5 minus 5 times ln 7 minus ln 5. 7 minus 5 is 2. So it's going to be 2 minus 5 ln 7/5. Kind of a funky, bizarre answer there. But that's how we do a U substitution in that scenario. Okay? And again, if you look at the prompt here, we had a binomial on the bottom and a monomial on top, and they were the same powers, right? X to the first power. All right, that's it for today. I'll see you guys tomorrow. 2 chains, bye.